Very general review of the function of the lymphatic system as it relates to capillary beds. In this simple graffiti right here, we're focusing on a grossly oversimplified version of arteries, capillaries, and veins. In this grossly oversimplified story right here, the arterial or arteriole blood hydrostatic pressure is relatively large. Let's say, for example, 40 units. The venous blood hydrostatic pressure is relatively low. Let's say 20 units for conversation. Well, that means that on this end of the capillary, you'll be pushing fluid outward more so than this end right here. Now, trying to pull fluid into the blood will be the blood osmotic pressure. And as I try to indicate right here, the arterial blood hydrostatic pressure is greater than the blood osmotic pressure. So on this end of the capillary, you would push fluid out. On this end of the capillary, the blood osmotic pressure hasn't changed, but the blood hydrostatic pressure has gone down. And now the blood osmotic pressure is greater than the blood hydrostatic pressure in the vein, this side. And so therefore you can pull some fluid inside. So there's a kind of a flush, a kind of a fountain going on here, where on the arterial end, you're pushing out the fluids and nutrients, and on the venial side, you're trying to pull that material back inside. Now, this is an inefficient way of getting the materials back inside, and a small portion of this exudate, this material that was pushed out, is going to be left behind. About 10 to 15% of the material that got pushed out isn't reclaimed at that capillary bed. Instead, it becomes necessary to have an alternate drainage system, and that's one of the things that the lymphatic system does. So it picks up that excess 10 to 15% of fluid not captured over here, and then it eventually drains it back so that it can be returned to the venous blood. Now, the place where it's most commonly returned is here at the internal jugulars, at the base of the internal jugulars in the brachiocephalic veins. The fluid drops in here, mixes back with the blood inside the superior vena cava, then it's thrown into the right atrium, the right ventricle, and again, you're remixing the material. Now, the volume of lymph that you have to reclaim during the day is approximately 3 liters, which is very significant because please remember, you only have 5 liters of blood. You have about 3 liters of plasma, so this right here is a very large amount of fluid, equivalent to the total plasma inside the blood. So the lymphatic system is an alternate drainage system. Now, along with being an alternate drainage system, there are also lymph nodes along the way which have the opportunity to look at the lymph and judge whether it's safe or not. So inside the lymph nodes, you might have macrophages, T cells, B cells, and these things have the opportunity to see what's coming downstream because lymph is just the interstitial fluid that has gotten inside of a lymph vessel. The only difference between interstitial fluid and lymph is location. The only significant difference, or the most significant difference between plasma and interstitial fluid is that plasma tends to usually have more proteins inside. And then the interstitial fluid, usually less because they don't usually leave the blood. If they did, they would pretty much destroy the blood osmotic pressure. Anyway, whatever does get out into the interstitial fluid is picked up by the lymph capillaries and eventually dropped back into the blood. Now, also being dropped back into blood could be antibodies produced by B cells in the lymph nodes that recognize the target. You could also have T cells that have in essence jumped off the nodes and they started traveling looking for their target. And of course, there's macrophages, which are sort of wandering through everything, looking at stuff, sampling at stuff, and then getting back into the general circulation. If your lymphatic system is working, you have a chance of preventing edema also because it drains away any excess fluid, even that excess fluid accumulated due to inflammation. Or if for some reason your venous blood pressure went up and this outward push right here was greater, then you'd have edema. Or if for some reason your blood osmotic pressure went down, perhaps you don't have enough albumin inside because something's wrong with your liver. That would cause edema. If the interstitial fluid osmotic pressure went up, that could cause edema. Perhaps a cell broke out here, or perhaps there's bacteria or some other parasite or pathogen that is dropping proteins and other electrolytes into this region, causing the interstitial fluid osmotic pressure to go up. It would then compete with the blood osmotic pressure and try to pull the fluid back into the space. And of course, if for some reason the lymphatics were blocked, then you wouldn't be able to drain the fluid away and it would cause a backup.